Welcome, pilots of the virtual skies. In the sim world, it is now 6:51 in the morning on a beautiful fall day. It's October 21st. We are at Payne Field, Snohomish County Airport in Everett, Washington, home of the wide bodies. This is where Boeing builds the 747 jumbo jet, the 767 wide body, the 777, which that's what we're looking at right now. There's two variants, the 777-200 model, and this is the 777-300 model. It's also home of the 787 Dreamliner. And on this early fall morning, there is the largest building in the world in terms of interior volume. That's the Boeing Assembly Factory. And our intent today is to continue our series of cold and dark flights with different airplanes from PAE to LAX. 3 goals: compare and contrast real operations to flight sim operations. Number 2 goal is to give some of the reasons behind the procedures. And number 3 goal is to look at the airplane from a passenger point of view. I watch some other tutorials. I see how they're done, and they're very good procedural wise, but I think they fail to incorporate the whole experience of commercial operations. So this is a little bit of a fictitious scenario because there really aren't passenger operations here at Payne Field. I mentioned earlier in North America, we would almost always use jetways to board the airplane. But let's say we're going to have a load of passengers here going to Los Angeles, and we don't have a jetway available. Very common in Europe to use buses and stairs. So we're going to use an add-on program called GSX. Go ahead and pull up the main menu and operate stairs. We get to choose a livery, and let's just choose Delta Airlines. One of the early steps that I'm going to want to do, and you can see those pallet loaders available on the other side, we're going to want to open up the cargo doors fore and aft and allow them to get their pallets loaded. This is actually how it's really done. Notice how those stairs, they stop short of the airplane and then extended the stair to the needed elevation and then slowly creep up on the airplane so their boarding door is in place. Let's hop aboard this cold and dark aircraft. First thing we're going to want to do is get some power aboard. Notice, if you were with me on the 747 and also the 737, this overhead is a lot less complex. Even though it is just as complex as the planes we've flown before, it is by far the simplest of the commercial airplanes to fly. So here we go. Here we're going to number these panels from left to right. The number 1 panel from bottom to top. The number 2 panel just second from the left. Number 3 panel and the number 4 panel. On the number 1 panel in the middle, you can see where it says electrical. We're going to hit that battery switch. And then just to the left of that, I'm going to turn this APU dial 1 notch over to on. And then the second notch is a spring-loaded position. And let's say you're going to start your old 57 Chevy Bel Air. You wouldn't immediately turn the key on and then bring it back to on. That wouldn't fire up the APU. And just as is true here, now it's not simulated in this program. The switch will come immediately back on to on. But in real life, you want to turn it to start. You want to hold it for about 2 seconds and then let the spring load bring it back to the on position. So there it goes. You really can't tell that anything has happened. That APU is way in the back, and it's going to take a little time for it to fire up. Let's cheat a little bit and go to an exterior view back there and see if we can watch, or at least hear, see if we can hear that APU fire up. It's a turbine engine. It's the same type of engine that we're using for propulsion. It's like a little baby jet engine tucked into the back of the airplane. Some 737s don't come with an APU, but every 777 has one. There we go. Let's go back inside. You can see we've got some limited power available now. I want to turn on the fuel pumps left and right. I don't know if I have fuel in the center tank. The APU will run for a little while without the fuel pumps on, but eventually it will need fuel under pressure. First thing I want to do is go down here to the very bottom of what we're looking at, to the forward part of the overhead. The switch to the furthest left of this row of black buttons, push the beacon button on, let people outside know that we're working on the airplane, and then immediately go up to the top of the number 2 panel and flip on that guarded cover where it says emergency lights, and that'll turn on the exit lights inside the cabin. Also, we want to, just to the left of the battery switch, we want to make sure the passenger cabin seats and utility lights are on, and then we want to go to the right below, on the lower portion of the number 2 panel. We'll make sure our no smoking sign is on, and more importantly, make sure our seatbelt sign is on. And just above that, the hydraulic panel, I want to turn each of these demand dials to the auto position, and I want to turn the center 2 buttons, push them so they say on, and we'll get hydraulic operation going. Also, at the very upper part of the number 1 panel on the left, I want to push this KDIRU button. That's our inertial reference IRS system, and we'll push that to get the IRSs starting to align. I'm going to come down here to our FMC, flight management computer, and I'm going to open up those cargo doors and allow those pallet loaders to do their job. Let's go outside and take a look. There they go. And let's go to our GSX menu now that we have those doors open. Go to GSX menu and start the boarding. Put these folks aboard. And look at that, here comes a little white van, that little white shuttle van that is carrying our flight crew and our cabin crew. Now it's kind of unrealistic that we went ahead and did those first several procedures without actually having the flight crew aboard. For the purposes of this loading, I'm just going to assume that maybe a ground worker started those first steps and got those cargo doors open. And then once we got our flight crew aboard, it can continue on with the process. Oh, look what also is coming. You can see that there's a tug carrying our palletized cargo and also some open suitcases. So there's our crew van. There's our palletized cargo. It'll be here soon enough. I'm always amazed at tutorials that start right on the flight deck, and they really fail to capture some of the whole airport operations. There's a lot of moving parts in an airline, and you know, if you don't simulate the baggage loading and the passenger loading and all the ground connections, you really lose some of the immersion. There's our dashing heroes. You can see there's our pilot flying and our pilot monitoring, or pilot not flying. It's kind of funny. You can see there's already 2 crew members aboard. But there's our dashing heroes ready aboard. Start to get our cabin crew on. Don't exactly know how many cabin crew we have. Notice that we do have our chocks under our tires, but we don't have any other ground connections. In the flight sim menu, I can add what's called a puffer unit, adding pressurized air for engine start. You can have an external air conditioning unit, which would cool the cabin. We can have an external electrical power unit, and it is possible to do all these startup procedures without actually turning on the APU. Right now our APU is operating. There's our cabin attendants. I don't know how many there will be, but we'll let them do their job. I mentioned in an earlier video that this airplane, you can actually start the engines with the air conditioning packs on. So I'm going to turn here on the number 4 panel near the top. I'm going to turn on the left pack and the right pack, get the air conditioning started. And I'm also going to, right below that, turn on the APU bleed button. We're going to need that high pressure bleed air. It's in the auto position when we get ready to start the engines. Let's talk about our route. We are going to Los Angeles. Before we talk about our route, let's actually go to our fuel and payload. You don't need much. Right now we're at 99.9% fuel. We are bringing to the max with fuel. Believe it or not, this airplane is designed as an intercontinental traveler flying over oceans. So we can get by with short-range fuel. That's only 18.7% into fuel. The airplane rise very precipitously, very quickly when we change the fuel level to short range. And I'm also going to go back and do our payload, and we'll put in random. So we've got 5 out of 8 first class, 24 out of 42 business class, and 173 out of 304 first economy, and then a random amount of cargo. So that'll be good. We're going to recognize that our information is out of date. Enter inertial position. We turn on our add a route button. You remember that from up at the top. So go to the position initialization screen. We'll take our GPS coordinates, put them in the scratch pad, and then immediately into IRS position. Our reference today is KPAE. I did work up a flight plan on the free flight sim planning program called SimBrief, so I don't have to enter in all the waypoints today. I can add what's called a company route. The destination is KLAX, and to add the company route, just identify the origin airport, the destination airport, I don't need a reference number in this case. Put it under company route, activate, execute, and we can, oh my goodness, not in the database. I don't know. Oh, I spelled things a little incorrectly. KLAX, there we go. Company route, activate, execute. Here we go, let's go to our legs page. There's exactly what we were expecting. SEA, Teoma, Suma, Jinmo, Jojin. Junjay, Jaguar, and Boom. And that'll get us started on our flight. Again, when we get closer to Los Angeles, we'll finish up. Departure, there are no SIDS. I know that the runway is either going to be 16 right or 34 left, because those are the only ones long enough for our aircraft. We don't know what that's going to be until we get a chance to listen to the ATIS, the Automated Terminal Information System. So let's... Oh, you can see our first passenger bus is starting to arrive. Folks are starting to board. Let's go to our map. Zoom in on Kane Field, and this number right in blue, right Snohomish County Airport. Here's a list of the radio frequencies, and we can see that we are at a... Here's our weather. We get our altimeter setting, ATIS frequency 128.65, and we are at 570 feet elevation. 128.65. Turn on our speakers.
Airport information, Romeo, 1413 wind call. Visibility greater than 20 miles. Sky condition, no clouds below 0 clouds. Temperature 2.4, altimeter 29992. Visual, runway 16, right-hand visual, runway 16, left in use. Landing in departure, runway 16, right in runway 16, left. All aircraft duration of flight. All aircraft require control instructions. Advise control on initial contact you have Romeo. Airport information, Romeo, 1413.
We have our ATIS recorded information of a routine nature. We know we're going to be on runway 16 right. And now I turn the left dial over to the barrel position, and I'm now rolling in our decision height. If we should need to come back to this airport immediately, remember our airport elevation is 570, so I want to add 200 feet to that, and I want our arrow to be at 770, and that's going to be the land, no land decision should we lose reference to the runway coming in on a return back to this airport. When we get to Los Angeles, that airport is right down on sea level. I believe it's like 5 or 10 feet elevation. And we're going to want to reset this barrel once we are in the air and on our way to Los Angeles. Right now we're looking for 770. I wish this dial operated a little bit faster. There we go. Okay, let's move our TCAS, Traffic Collision and Avoidance System. Here on the right-hand dial on our radio stack, move this dial from its far left position 1 2, 3, clicks over to the TA, or the ground setting, not all the way over to TARA. We'll hold that off until we're near the runway. And that will allow the ground controller to track our movements. We will want to get our flight planning and our clearance. We're traveling today from Snohomish County, Payne Field. Our destination is KLAX. We are flying IFR, and we're using not Victor Airways, the low airways. We are using Jetways, which are the high altitude airways. And you can see our route is very much the same as what's loaded into our computer. PAE, SEA, Teoma, Suma. Some of these extra waypoints I mentioned, we're going to be flying on Jetway number 5, J5. That's made up of a number of different waypoints. So when you say J5, it's automatically assumed that all those accompanying waypoints are included. So that will be fine. Let's get our clearance.
Airport information. Handler delivery 773 Heavy, Liberty Copy IFR clear to Los Angeles. 773 Heavy clear to Los Angeles Airport Panama. Fly runway heading, climb base 814,000. Departure frequency is 120.1, squawk 2552.
That's a little unrealistic, getting 14,000 initial clearance.
773 Heavy clear to Los Angeles Airport Panama. Fly runway heading, climb base 814,000. Departure 120.1, squawk 2552. 773 Heavy, reback to correct. Contact ground on 121.8 when ready to taxi.
Usually your initial clearance will be less than 10,000 feet. Keeps you under the 250 knot speed limit. Above 10,000, that speed limit goes away. So generally, your first step will be in the 7,000 to 10,000 range. And then you might get 15,000 to 19,000 as a next step. And then you would eventually be cleared to your cruise altitude. We've done our flight planning with a alternate at KONT Airport. It's about 90 miles to the west of LAX, and our requested cruise altitude is flight level 370 or 37,000 feet. So we don't have any SIDS or standard instrument departures at this airport, but we do know we're going to be on runway 16 right now. Let's put in our performance information. Our zero fuel weight is 456,535, and let's see what the computer has. 459. That's really close, so we'll leave that just as it is. Actually, what I can do is I can type in. I believe I can type in. Also, I've never tried this before. 456.5 or 46. Let's see if it'll take it. Ah, it did take it. Okay. And that makes our gross weight, our gross weight, takeoff weight, 508,911 is what I calculated. 509. So we're a little heavier than that in our actual load, which is fine. We're going to go 05 on the reserves. Cruise altitude of 370. Cost index of 85. Remember, the higher this number is, the less efficient you can operate. That number is determined by the company. We're going to derate our takeoff to the number 2 level, or 20%. This is the most derated that you can automatically set the airplane for. There's another way of derating the airplane. If you were to choose an outside temperature, right now we're at 14 degrees Celsius, you can look at the center EFIS panel, and you can see it here on the left side. It says 14 degrees Celsius. If we were to select a different outside temperature, we would fool the computer, and the computer would give us a derated takeoff that was based on a not accurate outside air temperature. And that's a way of getting a different derate if you wanted to. We're going to have a normal climb. Flaps are going to be initially set to 15. You know, that's one of the things I really intended to do earlier. Let's move our flap lever to the takeoff position. I hope our pilot not flying does not happen to be standing under the flap lever at this time. I want to bonk him in the head. There we go, takeoff flaps. One of the first things you should do is get in those flaps so that the pilot not flying can check for any misalignment or any binding of the surfaces. Okay, we'll let the airplane figure out our center of gravity. Center of gravity. We have a trim level of 7.00. I don't think we're going to be initially set up for that. Oh, you can see it's set at 4, nose down 4 degrees, but that will change automatically, I believe. And we can verify our reference speeds. Notice these are much lower than they would be on the 747. Our V2 speed being so critical, we're going to move that upstairs real fast. Oops. It's 152. I also want to tune our heading bug to our runway heading of 160. When we take off, we're going to be on runway heading, getting a vector onto our planned route. And we want to have that indication on our primary display to help us out. Okay, flight director's on. As I mentioned earlier in another video, I like to have the takeoff reference page on one screen, and then I also like to have the legs page on the other screen. We do not have to plan a pushback, so we're pretty much done. Let's monitor our boarding process. Folks are slowly getting aboard. I know this process takes a while. I'm going to cheat a little bit. We are at 99, 100, just 101 out of 365. So we're just shy of 1/3 the way done. I'm going to go to the options simulation rate, and I'm going to kick this up to 4 times speed. We're going to get those folks aboard a whole lot faster. Let's go back aboard. One thing I wanted to look at. On this lower EFIS panel, normally in operation you would leave it on engine performance as it is right now. But there are several other modes you can select. You can look at the electronic system. You can look at the hydraulics. You can look at the fuel. Oh, nothing in the center tanks. You can look at the air conditioning. You can look at the doors page. can look at the landing gear, all the tire pressures, and then you can look at the flight control page. This is something you really want to do, especially when the pilot not flying is returned from his walk around. And I've not done this in several of my previous flights. It's really a good habit to get into. You want to check not only the full movement of each flight surface, but you want to check for the correct movement. This airplane is what's called fly-by-wire. What that means is when I move the stick in a direction, electronic impulses are going to go back to the flight surfaces, and they're going to interpret my motion into a corresponding movement of the surface. There are no cables and pulleys that directly connect the yoke to the flight surface. Now, in a smaller airplane or in an older airplane that's not fly-by-wire, that's exactly what would happen. So in those airplanes, not only do you want to make sure that you've got full motion, but you also want to make sure you have correct motion. During maintenance, your cables could have been misstrung, and then when you move let's say you move the elevators back, instead of getting the motion that you would want, you go opposite motion. So we're looking for free, non-binding, and correct motion in all directions. And I can move the ailerons and the spoilers left and right. I can move the elevator up and down. I can move the rudder with a twisting motion. There's the rudder back and forth. You can see the rudder pedals moving back and forth. My airplane the rudder is manipulated by the pedals. And then one other thing you want to do is move the spoiler lever back and forth, and watch those spoilers. Those are small panels on the upper surfaces of the wings. You want to make sure that those move as well. So all the way they should be. Let's go back to the engine page. And that's how you're usually going to have it during flight. What I like to do on the number one pilot flying side, I like to start out with a range of 20 nautical miles range. And then on the pilot not flying side, I like his range to either be 5 or 10. That's fine. We could also set in our ILS frequency for runway 16 right, in case we had occasion to come back to this airport. So let's go to nav, map, choose the airport, click on the, and there you can see all the frequencies. Here's the runway lengths. You can see 16 right and 34 left are 9,000 feet. These are really long runways for the big jets. And our, I don't see the frequencies here, but I know they are going to be on the map. Okay, I know what I need to do. I need to zoom out a little bit. Here on the show ILS feathers, and you can see the green feathers and those, looks like a optical lens, these semi-ovals. That is the outer marker, the middle marker, and the inner marker. And here's something that I really like. Click on, first I'm going to get the ILS frequency, which is 1093. I'm going to remember that. And I also want to click way out here and get the ADF frequency, the outer marker ADF frequency. I don't see it right there. Zoom in, see if I can see 1093 on the. this outer marker has a frequency as well. Not showing it. I like to get that frequency and tune it in. It's called a NDB, or non-directional beacon. I use my ADF receiver to locate that, but I don't have it today, so just the ILS will have to do. Oh, okay, am I getting it here? Outer marker. Nope. .1093. You know, this 7, I've forgotten about this, about the 777. There is no NAV1, NAV2 radio here as in other airplanes. These are our COM1, COM2 radios, but the navigation radios are actually incorporated into the flight computer. So you would choose the nav radio button, and I want 1093 as the paid VOR. That's fine, but I want the 1093 in the number 1 radio. Interesting. It's not allowing me to put it in. Okay, well, I'm not going to worry so much about that. That's where the nav radio is. How are we doing on our loading, on our boarding? We are at the bus just left. Here comes another bus. The green bus is left. The blue bus is arriving. At 361 or 385. We're really close. I'm on this 365. This might be the last bus load. 371. 377. 382. Boarding is complete. Wonderful. Let's close the doors. only do I want to close those doors, but I want to arm them as well. And what that means is the next time you pull that big opening, if you do not disarm the door, it will, the emergency slides will deploy. So, yeah, the doors are all armed, and if you wanted to open them without the emergency slide, they would need to be disarmed first. Okay, our ground handling equipment is moved away. I will go to my ground connection screen. We do not have ground power installed. We do not have jetway plugs or air start unit or air conditioning unit. So let's remove, be sure the parking brake is on. Then we're going to remove the wheel chocks. And we can request taxi. Two mistakes there. First of all, I didn't get out of 4-time simulation mode, so it was a little faster. Secondly, I forgot a very critical step, and that is starting the engines. These engines are so easy to start, it's pathetic, it's crazy. Go up here to the number 3 panel at the top, push the auto start button to the on position as it is right now, and you don't have to turn off the air conditioning, and you don't have to do it one engine at a time. I'm going to go number 2 engine over to the start, it's going to stay there. Number 1 engine over to the start, the switch is going to stay there. And I'm going to come down here, supply fuel to number 2, supply fuel to number 1. And all I have to do is monitor the startup. Both engines at the same time. Amazingly simple. You hear that click? Click was the start switch returning back to its normal position. And all these yellow lights, the generator lights, the air conditioning pack lights, the bleed air lights, they're all going to go away. And we will be ready to taxi. We've been cleared to taxi, let's go. This airplane is so much simpler to taxi than 747. I only have 2 throttles to manipulate instead of all 4. And we're much lower to the ground. We are much higher than we would be in a 737. But in a lot of ways, this airplane is simpler than a 737. We are going to use the displaced threshold. Remember, that's that extra area of concrete beyond the main runway. And it can be used for taxi, it can be used for takeoff, but it cannot be used for landing. Still got to remember that even though it's nimble and it's only 2 engines, this is still classified as a heavy airline. mystery mode. Strobe lights on, turn off lights on, landing lights on, everything on. Let's go down to our TCAS switch and move that into the TARA position.
773, please acknowledge. Clear for takeoff, runway 16, right, 773, heavy.
Let's turn our weather radar on the pilot not flying side. We're going to turn the terrain radar on the pilot flying side. Our auto throttle is automatically in the on position. So we have our flight directors on. Let's take runway. Start the clock on our far left side. And hit the tow dial. Take off, go around. Just got the cabin ready indication from the crew. Now remember, the computer is only giving us enough power for a D-rated takeoff, so not getting the absolute full performance. Positive rate, you're up. First notch of flaps. Second notch of flaps.
773, contact Seattle, Bruce, 120.1. 120.1 for 773, heavy.
I'm going to turn off the terrain and weather radar because they're frame rate killers.
Seattle, Bruce, 773, heavy, and altitude 2,500 for 14,000. 773, heavy, Seattle, Bruce, roger, altimeter 2992. 773, heavy, turn left, heading 165, resume home navigation, climb and maintain 14,000. Turn left, heading 165, resume home navigation, climb and maintain 14,000. 773, heavy.
Now we're letting the FMC control our speed in the climb. You can see we are gaining speed and altitude at the same time. Ideally, the controller will give us a altitude beyond our initial climb altitude. We did make a mistake here. Notice here on the engine, upper engine panel, APU running. Oh my goodness, as soon as I started that engine, it was so simple a process, it's almost unbelievable. You should reach up over here and turn the APU switch to off. Again, there's no bus to worry about. The airplane will determine that all on its own. And notice the APU cool down indication. And let's go outside because we're going to fly over Seattle.
Contact Seattle Center, 1 to 80.
There's the University of Washington campus right below us. That's Husky Stadium. You can see the Seahawk and Mariners sports stadiums. There's Boeing Field. Flight testing for many Boeing airplanes happens there. Back in World War II, the top of this building was camouflaged to look like a residential neighborhood. That way, if potential Japanese bombers came overhead, they might not bomb an area that looked residential. Then just beyond Boeing Field, there's SeaTac Airport. Let's climb back inside. Getting close to our transition altitude. Above 10,000 feet, we can leave Christmas tree mode. We're going to leave the strobe light on here on the right-hand side. Turn off the taxi light. Turn off the one-way turn-off lights. Turn off the landing lights. Should have turned on the nav on the wing lights. Should have done that. We've crashed. I hate when the computer crashes. Okay, folks, we're going to try to continue that Los Angeles flight at a different time. But I hope you enjoyed the golden dark to taking off and on our initial way toward Los Angeles. We'll see you again.